Good morning. Today we're going to take a long look at what we've been doing over the last 2 weeks. We've learned how to balance chemical equations. We've learned how to calculate the molar mass. And we've learned reaction types. Today, we're going to put all those skill sets together into one cohesive thing that hopefully will make sense. I'm going to go through 2 problems right now, and then I'm going to unleash you to go attack the 4 problems that you'll have to do for your homework. We'll make it easy, hopefully, and make sure that it makes sense. So let's get started. Quick side note, Professor Daniel will not be joining us at the beginning of this video, but he did want to say something at the end and teach you guys something completely different about the world around you. So stick around for that, and we'll see you then. Now let's get busy working out the problems today. So when I say we're going to put everything together today, this is what I'm talking about. We've got a problem that only sets us up with the reactants. Now, if you'll notice, I've even added a little bit of layer of complexity by just giving you the names of the formulas and not directly the formulas. So step 1 here, what we're going to try to do is to write out the reactants clearly and correctly. So the very first one's not too bad. Dicarbon, that's got a prefix, so it tells me we're dealing with covalence. So I just simply write down what it tells me. That's going to be 2 carbons, so C2, tetrahydride. Tetra is 4, hydride is hydrogen, so H4. That's good so far. It's mixed with oxygen gas. Now, I know that oxygen gas is a diatomic molecule, and you should too. So we're going to add that to oxygen gas. It wants to know what the products are that are formed here. So that's when we put our yield sign. So I'm putting the lines here because we are going to need, if you look ahead to step 2, to balance the equation. But look what we have here. We just have the reactants. We need to go ahead and figure out from these reactants what kind of equation it is. Now, hopefully you were paying attention the other day, and this is the one that I saved for last because it's so iconically easy to identify. It's a hydrocarbon and oxygen gas. That's right, this is a combustion reaction. So we know that all combustion reactions are going to create carbon dioxide and water. So we're going to put those as our products listed on the product side. Give yourself space to balance. We know it's going to make CO2 plus coefficient space water. Good old dihydrogen monoxide. So there it is. So far, we've done the task of predicting the products. Step 1 complete. Now, we need to balance it. This, I can't stress that you just need a lot of practice at. If you're struggling with this, or maybe if it's making a lot of sense and you, weirdly enough, might find it a lot of fun, just keep doing it. The 4 problems I've given you for homework are just like this, except instead of the words, I've given you the actual reactant equations, so it takes that anxiety away. Now, step 1 in balancing, draw yourself a line. You've got carbon, you've got hydrogen, you've got oxygen. Same goes for the other side. And you've got 2, 4, 2. Over here, we're going to have 1, we're going to have 2, and we're going to have 3. Again, the 2 oxygens plus the 1 other oxygen. Make sure you're adding across that side. So for the product side, you get a total of 3 here. All of them are unbalanced, so technically speaking, let's go ahead and start with carbon. You can start with whatever you'd like. I'm going to start with carbon. I'm going to put a 2 on the carbon dioxide of the product side as a coefficient. And it's going to change 2 things. It's going to change carbon, and it's going to change oxygen. So a 2 right here puts my carbons to 2, and it's going to change my oxygens to 4, plus 1 more, which is 5. Now, my hydrogens and my oxygens are the only 2 things that are out of balance, and I need more of them on this side for hydrogens. So let's go ahead and try to fix that. So hydrogens to go from 2 to 4. If we go over to our water on the product side, we can place a 2 in the coefficient here. That 2 brings hydrogen. 2 times 2 is 4. 2 times 1 oxygen atom is 2, plus the 4 that we already have over here. So this 5 goes to a 6, and we're almost done. I need to go back and fix the oxygen on the reactant side. Unfortunately, it's all alone, so I won't change anything else once I move it. So our coefficient over here to go from 2 to a 6, you guessed it, it's a 3. So 3 times 2 is 6, and now we are balanced. Finally, the last step is to ask yourself which product, that being carbon dioxide or water, contains the most mass at the end of the reaction. So what you've got to do is figure out the molar mass of how much carbon dioxide was made and the molar mass of how much water was made. Now, this includes the coefficients. So make sure that you realize you have 2 moles of each of these products. So we'll do some quick calculation. To do this, you're going to need your periodic table. And I happen to have mine right here. Let's list the molar masses of each of these. So for carbon, you've got a molar mass. You bring in your periodic table here. For carbon, that is 12.011. For oxygen, we've got 15.99. And of course, for hydrogen over here, you've got 1.008. So we have our grams per mole of all 3 elements involved. Now we got to do is just simply add them up and then multiply by the coefficient, and we'll get our answer. So let's do that. It slipped down there, so I'm giving you a second to look over everything we've done so far. Now let's move on to doing the molar mass of carbon dioxide and water. So here we are, just a little bit more zoomed in. We still have our 3 elements and their 3 molar masses, grams per mole for each. We take a look at carbon dioxide here. There's 1 carbon, so I do 1 times its molar mass. Then I'm going to add that to oxygen. There are 2 of them times its molar mass. When you add that up, you're going to get 43.991. That's grams per mole. Now remember, that's how many grams 1 mole of carbon dioxide weighs. But we did not have 1 mole of carbon dioxide. We had a coefficient of 2. So we're going to multiply this number by 2. And what you're going to get at the end of the day for your final answer for carbon dioxide is 87.982 grams. That's how many grams 2 moles of CO2 equals. And that's what we made in our chemical equation. We made 87.982 grams because we made 2 moles of carbon dioxide when you look back at the chemical equation that we have here. Now we need to just compare that to water, H2O. We're going to go through the same exact process for H2O, of which there are 2 moles of. We're going to take our hydrogen. There are 2 hydrogen atoms times our molar mass of 1.008 grams per mole. And we're going to add that to our oxygen, which is times 1, and that's 15.99 grams per mole. Again, simply add it up, and what you get is 18.006 grams per mole. Again, we don't have 1 mole of it, we have 2 moles of it. So I'm going to take this number and multiply it by 2, and you should get 36.012 grams is equal to 2 moles of water. Now, when we compare this number to this number, we finally have an answer for our third question. Which one has more mass at the end of the reaction? It's clearly carbon dioxide. Carbon dioxide comes in with 87.98, whereas water comes in with 36.02. So carbon dioxide wins with 87.98 grams versus water with 36.01 grams. So that's how you solve the final step. And that's putting everything together. We have literally taken 4 class periods and broken down not only what a chemical equation is, we talked next about how to balance a chemical equation, then we talked about calculating molar masses, and then finally we talked about identifying reaction types. All those steps were to build you up to be able to do a problem just like this. Now, you can go back and review this question. I'm going to do one more just to make sure we're clear on all the things that we're doing here. So let's step over and try that problem really quickly. Okay, so here we are again. Another problem. Let's make sure that this makes sense before you head off to your homework. Now, I'm going to give you the first steps. What's being mixed together to have a chemical reaction? So when you mix magnesium, magnesium's just a metal. We've seen it before. Magnesium is just Mg. It's not a gas, so you don't have to write a 2 or anything like that. Magnesium is just magnesium. And when you mix that with iron 3 oxide, now remember, that iron 3, that 3 there tells you the charge, plus 3 of iron. Iron is Fe. We have a plus 3. Oxygen is oxide. It's a minus 2. The old switcheroo works here just fine. Iron's going to need 2 iron atoms, 3 oxygen atoms. Will balance that out nicely. Now we want to know what happens. Okay, trying to figure out what type of products we're going to form really comes back to, do you remember what we learned yesterday, which is what type of chemical reactions there are. This is one element plus a compound. Hopefully that just rang a bunch of bells and you are dealing with a single replacement reaction. That's right, but the cations are going to switch places. So iron gets kicked out. That's Fe. Leave ourselves a space there. And we're going to add that. Now, it doesn't matter about iron's charge. It just is removed as a solid, okay? So after it's removed as a solid, magnesium, now its charge does matter. And remember, magnesium's right here on the periodic table. That's going to be a group 2 alkaline earth metal, which means magnesium is a plus 2. And it's mixing with oxygen, which is a minus 2. So those exchange of electrons are even. So you get 1 magnesium to 1 iron ratio. So we're going to have MgO. Let's throw this in there just for fun. OMG. That's right. We made MgO. Now, step 1 is complete. We know what our products are based on what the reactants were. So now we're going to go through the process of balancing it. Pay attention here to what I'm doing and make it so that you can see everything that I'm doing. So we're going to go through this and balance the equation. We've got magnesium, we've got iron, and we've got oxygen. We've got magnesium, we've got iron, and we've got oxygen. On this side we have 1, 2, 3. Over here they're all 1s. So what we've got to do is figure out how this ratio is going to come together correctly. So magnesium's already balanced. We can fix iron pretty quickly. If we go over here, we see that all we need to do is put a 2 for this coefficient. Now this is where it becomes a little bit tricky. We're going to mess up magnesium, but remember, it's all alone on this side. And we're going to mess up oxygen, and that's what we want to do to get iron and oxygen equal. Now, this step is probably going to take a couple of back and forths to get it right, because we're going to mess up iron and oxygen and everything. But let's start with oxygen. How are we going to fix it? Well, we need a 3 here, right? So a 3 here puts magnesium at a 3. It puts oxygen at a 3. That's great. I forgot to change my iron here. Thanks for catching that, those of you yelling at the screen right now. Magnesium, iron, and oxygen on this side look stable. The only thing that needs to be changed is our magnesium over here, which we can fix again because it's all alone. 3. We've now balanced our chemical equation. The final step, which product of these two contains the most mass at the end of the reaction? Well, because we're looking at moles of these, but because one of them is a single element, let's take a look. If we look at the periodic table here, iron is 55.84. So iron, 55.8. And if we take 55.8 and multiply it by the 2 moles of iron that we already have here, we're going to get 111.6 grams is equal to the 2 moles of iron. Is everybody catching on there? Now we're going to do magnesium and oxygen. Magnesium on the periodic table is 24.3. 24.3. Oxygen is 15.99. We get out our trusty calculator. 24.3 plus 15.99 is going to give us, added together, a number of 40.29. Now, we have to remember it's times 3. This number gets multiplied by 3. And what we get, it's a close one here, is 100, and 20.87. So be careful. Even though this was the bigger molecule, and yes, it had more moles, it does come out on top, but only by a couple of grams. So our magnesium oxide is what wins, and now we've solved step 3. I hope this is making sense to you. I hope that you can go on and take some of those challenging questions that I've got waiting for you in the homework and just knock them out of the park. We're going to have our homework due at the beginning of Monday on noon. So Monday at noon is when you have to have your homework completed and submitted. Make sure you get that done. And now a brief message from Daniel with a little experiment he wanted to show you. Okay. That's you.
Oh.
Well, hey Daniel, how are you doing today?
Good.
You want to know what I'm doing?
What?
I'm driving this stake into the ground, and guess what? Since the sun's out, it's casting a shadow. Do you see that shadow?
Yeah.
Now I'm going to try to use that shadow to figure out which direction is north, okay?
Might be that way.
Maybe. You know what we're going to need?
What?
Some kind of flag or something that we could put at the end of this shadow. Would you have one?
Yeah, I'll be right back.
Okay.
Hey, could you give me a flag? Take 2. Here's a flag.
Perfect. Let's come over here and put it at the end of this shadow. There you go. Now guess what, Daniel?
What?
We're on which planet?
Earth.
okay? And Earth goes like this, right? It turns. But the sun is way out here, and as we turn, it looks like the sun's going across the sky. So I bet if we come back in about 15 minutes, this shadow is gonna move. What do you say we come back in 15 minutes to find out?
Yeah.
All right, let's go.
Yeah.
Daniel, we're gonna place your stick down right here. And what's gonna happen is since the earth moves and the sun moves across the sky from east to west, then as it moves in this direction, what we know is it started over here. So that would mean that this is west and that this is east, because it's actually going that way to set, okay? So what that means, Daniel, is that that way should be north. And you know how we're gonna check it?
Yeah.
We're gonna lay this down right here. Now, we get the flag out of the way so we can see it. Now, look at how we're gonna check it too. You know what this is?
Yeah.
What is it called?
A clock.
Close. It's a compass. You want to set the compass down on top of that for me?
Yeah.
Why don't you set it down on top of there? All right. Well, if we can get to take a look at this, what we're actually seeing here is that north is pointing north, west is west, and east is east. Can you see that, Daniel?
Yeah.
Cool. So it worked. This is called the stick and shadow technique for finding true north in the northern hemisphere, of course.